Hello, my name is Darren Thomas and I'm the Director of Educational Research Techniques. In this particular video, we're going to look at an application of solving for a system of equations, but this time in particular, we're going to look at solving for three variables. So, three variables is what we're looking at. And so why don't we go ahead and take a look at how to do this. So here's our question. A bus company had to sell tickets by hand. I guess they had a mechanical problem with their computers. First class tickets were $15, second class tickets were $10, and third class tickets were $8. The bus company sold 250 tickets and made $2,825 in sales. The number of second class tickets was twice as many as first class tickets. How many first, second, and third class tickets did the company sell? So let's figure out, what do we know. First of all, we know that there are three classes. So we got first class, second class, and third class. And we don't know how many tickets we sold for each class. That's where our variable is coming from. We also know how much each ticket was worth: $15, $10, and $8. We also have an idea. We also know how much we made, how many tickets we sold, and how much money we made, or how much our sales were, our revenue, if you will. And another clue that we have here is how many second class tickets we sold compared to first class tickets, which is this sentence right here. So this is the information we know. Now, whenever you're trying to solve, this is basically like some sort of a mixture problem, if you will. You want to, let me see if I can make this nice and clear for you. You want to set up your table. So it's going to be type, followed by number, which is going to be like our variables, multiplied by our value is going to equal our total. That's what's going to happen. And so what we have here is we have first class, second class, and third class. That's what we have. So let me just go ahead and draw my little table here. Try to make this somewhat neat for you. That's what we have. And so we're going to have, for our first variable, first class is going to be x. Let me make this a different color, a little bit easier to stand out, if you will. So x, y for second class, and z for third class. That's what we have there. And then we know that the value is going to be $15 for the first class, $10 for the second class, and $8 for the third class. That's what we have. And so we know our total value is going to be something along the lines of 15x, then also 10y, and also 8z. And something I forgot to put down here was how much did we make? That'll be right here. So $2,825. Yes. And then also for the total number of tickets, we know that the total number of tickets is going to be 250. So this is all the information that we have set up in a table. And so if we take our knowledge here, we can actually convert these into equations. But there's something I want to emphasize before I do all of my equations here. And that is this information right here. We know that the second class tickets was twice as many as the first class. So what that's basically telling us is, if we were to write that out before I finish up my goal here, is that y, which stands for my second class tickets, is twice as many as my first class tickets, which is x. Another way to write this is you could put it as 2x minus y equals 0. So basically I just subtracted the y. This is going to be one of our equations. So you can see that for one of our equations, we don't have three variables. We only have two. This is going to be key in a second. Now, having said this, I'm going to go to the next screen and set up my other equations for you as well. So this is what I have. I have x plus y plus z equals 250. This is one of my equations. This is the first column right here of my data that I have. And so my second equation is going to be 15x plus 10y plus 8z equals 2825. Now, where does that come from? It comes from this column right here. And then the last equation is going to be this guy down here at the bottom, right here. We solved him a few moments ago. So my last equation is going to be, now what we're going to do here is we're going to multiply that by negative 2x, because my first goal is going to be to eliminate one of the y's. So negative 2x, now it's going to be a positive y equals 0. So what did I do here? For this last equation, I multiplied it by negative 1. So it became negative 2x, and it became positive 1. This will make more sense in a second, but this is what I have so far. Now, the first thing I want to do is I'm going to work with the first two equations. So let's see here. I'm going to work with the x plus y plus z equals 250, and I'm going to work with the 15x plus 10y plus 10z. So let me go ahead and zone that off for you. Let's see here. Make it a little bit easier to see. And so what do I need to do? Well, I want to multiply the top one by negative 8. If I multiply this top equation by negative 8, I can cancel out the z's. That's going to be my first goal. So here's what's going to happen. So I have negative 8x minus 8y minus 8z equals, so let's see here, negative 8 times 250 is going to be negative 2,000. That's what we have. Now what I did was I multiplied this guy right here by negative 8. That's what essentially I did. And of course I did it to both sides. That's what we did here. So if I take the second equation, I have 15x, this has not changed, plus 10y plus 8z equals 2825. Now I add these up and I get 7x. Let me just change that real quick. I get 7x plus 2y. The z's cancel out, they're gone. Equals negative 2,000 plus 2,825 is going to be 825. So we've already made progress here. Now, the next thing we have to do here is we have to deal with this equation. And we're going to have it work with this new equation that we just created right here. Whoops. All right, so I got a little bit of space over here. Let me see if I can squeeze this in over here. So this is what I have. Now what I need to do now is that I need this to be a negative 2. So what I'll do is I'm going to multiply this equation right here, negative 2x plus y, by negative 2. If I do that, I will have positive 4x minus 2y. And then I can combine it with my second equation here. So please watch carefully. So negative 2x times negative 2 is going to be 4x. Y times negative 2 is going to be, of course, negative 2, and it still equals 0. Now, my second equation down here, 7x plus 2y. 7x plus 2y equals 825. And again, I combine these like I've done several times before. And so I think you have an idea of what to expect here. These cancel out, and I'm left with 11x equals 825. This is the basic equation. Divide both sides by 11, and you get x equals 75. So I have now solved for x. It was a lot of work, but it is done. And so things begin to pick up. But I want to make sure things are clear before I go any further. Basically, what I did here, how did I get the 4x minus 2y? I multiplied this original equation right here by negative 2. That's what I did. By multiplying this by negative 2, I was able to get a negative 2y. And this negative 2y is able to cancel out this positive 2y down here. And so now I have x equals 75. How did I get that? Well, I combined the equations, and then I divided like a normal equation, and I got the answer. So, having said that, why don't we wrap this up now? We know what x is. So if you look back here, we're going to use this equation right here, and we're going to plug in x, which is 75, to find out what y is. So let's do it. So remember our original equation here was negative 2x plus y equals 0. We now know that x equals 75, so we're going to plug it in. So negative 2 times 75 plus y equals 0. That means that negative 150 plus y equals 0. If I add 150 to both sides, maybe I should help you out a little bit here. If I add 150 to both sides, I get y equals 150. So now we know that y equals 150. We're making good progress here. So now all we have to do now is solve for z, which if you look way back at the beginning here, let me see here. The z was going to be x plus y plus z equals 250. So having said that, x is 75. Y is 150, and we don't know what z is yet, but we know that it equals 250 tickets. So this is basic math, nothing deep here. So 75 plus 150 is going to be 225 plus z equals 250. We subtract 225 from both sides, and we get our final number of z equals 25. So I put that right here. That's the last thing that we solved. So what can we say here? Well, x was our first class. So we had 75 first class tickets. Y was our second class. So we had 150 of those. And z was our third class. So we had 25 of those. And you can see here clearly that this adds up to 250. And you can actually even figure out if this meets the revenue requirement of $2,825. So again, you can see there's a lot of work to solving these applications by hand. But it's a lot of fun, and it's very realistic in terms of what you might actually experience occasionally in the real world. So let me see if I can try to make this clear for you. What we did in this video was we took a look at how to solve an actual application of solving an equation, a system of equation that has 3 variables. And so the first thing we did was we set up our table, but then there was a little hint inside the actual problem about how to deal with how many to solve the equation. And so what happened was there was a little hint about how many of the second class tickets compared to the first class tickets, and we put that information down here at the bottom as so. And so then after we set up our table, then we took the columns to set up our system of equations here. So this column and this column like so. The third equation was already set up for us down here at the bottom, and we got this information here. And so the first thing we did was we multiplied by 8 the top equation and the second equation, and that way we were able to eliminate the z. That's why we multiplied by negative 8, and we got this equation right here. We then took this equation right here at the bottom of the screen, we put it up here at the top, and we took our third equation right here from the original system and we multiplied it by negative 2. Alright, now we did that so that we can get a negative 2 right here that we can add together to cancel out the y's, and we're able to solve for x. Now one thing that I need to make clear is that our original equation was 2x minus y, but I multiplied it by negative 1 because I had a goal for it later on. So again, we know what x is, and then once you know what x is, it picked up quick. And so you plug in x to one of the original equations, which this is the third original equation, if you will, and we were quickly able to find out that y was 150. Once you know x and y, we took the original column equation right here, and we plugged it in simply, and we found out that z was 25, and that's pretty much how you do it. So I hope this video was useful for you. I know that there was a lot of complex steps here, and maybe things were hard to understand, but this is a very practical way to experience and enjoy some algebra and a system of equations. So my name is Darren Thomas. I am the Director of Educational Research Techniques. Thank you for listening.